So the topic that we are sharing today, it's logarithm. A lot of you guys has been requesting for it. So here it is. Hope you find it helpful. So before we start, I have to go through the core formula that was applicable to this topic. So the first one is, how do you change a indices to become logarithm form? So first you need to know who's the base, who's the power, who's the results. So over here we have A as the base, B is the power, and C is the results. And to transform it into logarithm, our base will be the 1 at the bottom left corner. The value next to it will be the results, and it will help you to figure out what's the power of A, which is on the other side. So we have this example over here. 2 to the power of x equals to 32,768. So normally when you encounter this type of question in your normal mathematics, you're required to figure out 2 to the power of what will get you to 32,768. So you have to key in your calculator, trial and error to get to it. So instead of relying on it, you can actually adopt this logarithm concept. So the log, we have a base of 2 now, and the value right next to it will be the 32,768. So key in your calculator, then you should be able to find your answer as 15. So this is the common application in your indices topic. So how do you change your indices to logarithm? The next one we have here is, I put a log A over there. So when you didn't see the base being specified, so it is actually fixed. The base will be 10. So log A can actually be interpreted as log with a base of 10 and the results of 8. Moving on, we have when your base and the results is the same, it will be equals to 1, because 10 to the power of 1 equals to 10, or 20 to the power of 1 is 20. So it is actually fixed. Moving on, we have log 100 here. Remember, when they didn't specify, means that the base will be 10. So 100 over there, we can actually change it into 10 to the power of 2. So in logarithm itself, when you have power, you can actually bring it out from the logarithm. So I can actually write it as 2 log with a base of 10 and the results of 10. And the results of this will be 2, because when your base and the result is the same, it will cancel off and become 1. 2 times 1, you will get 2 as your final results. Moving on, we have addition, which is log A plus log B here. Remember, in logarithm, when you see plus between logarithm, it's actually telling you that they can be multiplied together. So log A plus log B will be equivalent to log AB. However, there's a requirement here. Their base must be the same for the multiplication to be possible. Same thing, minus or subtraction will directly result in division. So we have log A minus log B. It can be interpreted as log A over B. Next one, we have changing the base. So we have log A, B over there. So in some type of question that we'll share later, they actually require you to adjust the base. So a new base was being introduced to you. So you will write it as log with a base of c, which is a new base that was set by the question. And the result of it at the numerator part will be the original value, which is b over there. And we divide it by log c, which is the base. And we take the original base, put right at the result section. So this might sound a little bit vague right now. However, later on when we go through the question, you'll be solely to understand it. The next one, you always see this link to logarithm topic. This IN here actually represent natural logarithm. So it qualifies as a natural logarithm because it has a e as a base. So if you wish to know more about this concept, I will leave a link in the description. You can go over there and check it out for the details. So IN A can be interpreted as log with a base of e and the results of a. Moving on, when we have INE, you can change it as log with a base of e and the results of e. Since the base and the results is the same, we cancel off and we become 1. To top this off, we have this example over here. Log with a base of 10 and results of 5 can be written as log 5, or the other short form that always appear in your exam. Okay, it is actually the same thing. Instead of log log, they just use the short form of lg. So it's the same thing, nothing to worry about. When you encounter it, don't panic. And there's 2 more things that I would like to share to you is that you have to make your own judgment on. You saw me listing down all the equal sign. Is actually 2 ways. You can represent the value in different form for the same logarithm. So you have to make your own judgment and see what's the most suitable for the question that you have there. So do take note on this. And also arrangement that was already there, you're not supposed to change it. Like if you have a logarithm at the numerator and a logarithm at the denominator, okay, so their relationship between a logarithm is already divided. You can't simply change it become minus again. So those are the little rules that might confuse you. Okay, that's what my students always struggle to understand. Remember the rules that was already been set. Please don't reverse it. Take note on this. Then later on when we go through the question, you'll be able to understand better. So moving on, we have the keynotes over here. These are the things that you need to know beforehand when you solve the question. So a couple of concepts that you have learned in your mathematics will be applicable here. We have concepts like simultaneous equation, substitution from your algebra, factorization from your algebra as well. Aside from all the topic that was linked here, there's a few types of questions that you need to take extra precaution. So you will notice you have proof that or show that type of question later on. So those are the questions that you need to ignore whatever that was given to you and only focus on one side and try to rearrange it and fulfill the requirement to show it is actually equivalent to whatever they are trying to ask you to prove or to show. Remember that I mentioned earlier, whichever form of the logarithm, you have to choose it wisely, else it will make your workings more complicated. So stay versatile. You can always adjust things, try it out before making your last decision. So when you look at the question, it's always good that you analyze it first, run some calculation in your mind, then only you approach the question. So to nail this topic itself, you need to have some basic understanding on the application of indices rule, like how the power is being interpreted or can be changed in different situations, as well as if the logarithm has negative results, you cannot use the negative results. So the negative will be invalid in logarithm question. So the reason why I share all this to you is to build up your basic understanding, so that when I share the examples later on, you'll be able to absorb better. So I've already chosen 6 types of questions from your past year. So I covered all the possible question type that might appear in your exam. Look through it. After the video, feel free to search up the respective paper, download them, and try it out. So without further ado, let's get started. So we have example 1 here. Show that log with a base of 9 and the results of 4 can be interpreted as log with a base of 3 and the results of 2. So remember, I mentioned earlier, ignore whatever value that they ask you to prove, put that aside. So I copy it down. We have log 9, 4. So by analyzing it, I know that they want me to change the base, and 3 and 9 is related, which means the one with the power concept is being adopted here. So I listed down the rules that might apply. So the first thing that I did there was to change the base. So my new base here, I set it as 3 because that's what's the base on the other side that they asked us to prove. Now that we've gotten these results here, you can look at the 4 and the 9 and make some adjustment to it. 4 can be interpreted as 2 to the power of 2. 9 can be interpreted as 3 to the power of 3. Bring out the power itself according to this rule over here. Now we have 2 log with a base of 3 and the results of 2 divided by 2 log with a base of 3 and the results of 3. So remember that I mentioned earlier, when the arrangement has already been done, you cannot reverse it. So I cannot write it as 2 log 3 2 minus 2 log 3 3. So these are the things to take note. Then we can move on and cross things off. So the 2 and 2 will be automatically cancelled, and the log with a base of 3 and the results of 3, since the base and the results is the same, it will be cancelled off. So we have the last results as log with a base of 3 and a result of 2. So this is how you solve this type of question. Moving on to part 2, hence solve log with a base of 9, 4 plus log with a base of 3, x equals to 3. So I list down the rules that's applicable here on the right hand side. The other thing is that since we already proved that log with a base of 9, 4 can be changed into log with a base of 3, 2. So I change it up. The plus then become multiplication. So I have log 2x equals to log 3 with a result of 3 to the power of 3. So you will notice, aside from multiplying 2 and x together, I actually did extra steps on converting the whole number of 3 into logarithm. So the base that I chose must be the same as the left hand side. So I set it as 3. So remember, we are required to be able to cancel it off. So I will set the results there as 3 as well, with a power of 3. Reason being, when the power was being extracted to the front, log with a base of 3 and the results of 3 will automatically cancel off each other. So that's the reasoning and the supporting information. Why did I write it as log with a base of 3 and the results of 3 to the power of 3? So now that both sides has log with a base of 3, we can now cancel them off and copy down whatever value the result is showing you. So we have 2x equals to 3 to the power of 3 now. So 3 to the power of 3 can be written as 27. So I divide it by 2 and you will get your final results as 13.5. And that's pretty much it for the first example. After looking at this first example, I hope that you have the basic idea already. So now let's move on to example 2. So what we have here is finding the value of negative log with a base of p and the results of p squared. So the rules that apply here will be the one bringing the power out. The first thing that I did was to shift out the power over there. So I got negative 2 log with a base of p and the results of p. Since the base and the results is the same, it will automatically cancel off. So we will now have negative 2 as our final answer. As for the next one, you will see algae over there. It's actually log with a base of 10. However, things that I did here was to apply the indices rule, where I bring the 10 to the power of n from the denominator to the numerator. So to make that possible, you can interpret it as log with a base of 10 and the results of 10 to the power of negative n. So same rules applied earlier, bring out the negative n now. And since the base and the result is the same, it will automatically cancel off and you will get your final results as negative n. Moving on to question 3. Here, show that log 20 minus log 4 divided by log 5, 10. So this part here, the minus, can be changed into divide. So the divide over there, you are not supposed to make any changes to it. And I noticed that the base of the numerator and denominator is different. So I will try to make them the same. So this is the part where you need to decide what base for you to follow. Should you adjust the numerator or you should adjust the denominator? This is where you need to take in the right hand side into consideration. So the right hand side over there show you algebraic square, right? So when they are algebraic and they didn't mention about the base, means it is 10 as the base. So from that, I know that my denominator need to be adjusted and change the base into 10. So I've written it down, log 20 divided by 4 over log 5, 10. I then move on to change the base. So log 20 divided by 4 become log 5. Log 5 divided by log 10. with a result of 10, and log 10 with a result of 5. So divide become multiply. Log 10, 10 will be cancelled off and become 1. So now we will have log 5 square, and the y will be 5. Moving on to part 4, we have log with a base of r 2x plus log with a base of r 3x equals to log with a base of r 600. So for this, plus will become multiplication. So we have log r 6x squared equals to log r 600. Since both sides has the same base, you can now cancel off the log and you will have 6x squared equals to 600. 600 divided by 6, then you will get x squared equals to 100. To get rid of the square, I put the square root over 100 and I will actually get plus minus 10. However, remember I mentioned earlier, it cannot be negative. So your x will be automatically taken as 10, and 10 will be your final result. Moving on to example 3, we have solve e to the power of 2x plus 1 equals to 3e to the power of 4 minus 3x. So for this, indices rule was being applied here, and you are required to change it into logarithm later on. So that's the rules that I assume that we'll be using when I'm looking at this question at the first glance. You need to practice more, then you will know which rule to apply when it comes to different questions. So first thing that I did was to shift the e to the left hand side from the 3 over there. So since they both have the same base, I bring the denominator up by putting a negative in front of them. So we have e to the power of 2x plus 1 minus bracket 4 minus 3x. So through this calculation, we will get our e as 5x minus 3. And I apply the logarithm here. Log with a base of e, the result of 3 will be equals to 5x minus 3. So log e here can be interpreted as natural logarithm. So I write in over there. So in 3 equals to 5x minus 3. Bring the minus 3 over, then become plus, and x will be in 3 plus 3 divided by 5. So to clean your calculator, after you correct it into 3 significant figures, and you get the results at 0.820 as your final answer. Moving on to part B, we have log y minus 6 plus log y plus 15 equals to 2. So plus here means that I have to change it into multiplication, and the 2 over there, we must also adjust it into logarithm form. So I list down the rules that we'll be using on the right hand side. Change it up. 2 can be interpreted as log with a base of 10, a result of 10 to the power of 2. So you now have y squared plus 9y minus 90 equals to 100. Since both sides has log, extract both the results over there and run the calculation. You should get y squared plus 9y minus 190. And through the factorization process, you will get two results here, which is y plus 19, y minus 10 equals to 0. And your answer will be 10 only because y equals to -19 is not accepted. So that will be your final result. Over at example 4, we have involvement of e again. So we have 5e to the power of 3x plus 4 equals to 14. So I know we will be using the natural logarithm concept here, and we are required to apply logarithm into this part. So first thing that I did was to shift the 5 to the other side, transform this into logarithm format. So we have log with base of e, 14 over 5 equals to 3x plus 4. Log with a base of e can be changed into natural logarithm. So x will now be in 14 over 5 minus 4, and divide entire thing by 3. And through the calculation, you get a final result as negative 0.990. Moving on to part 2, find log 2y minus x plus log y equals to 2 log 3. So the good thing about this question here is it saves up you some time, because at the right hand side of the equation is not a whole number anymore. It's already in logarithm form. So all you need to do is to get rid of the 2 at the front, shift it back into power. And the relationship for the two variables at the front is plus. It will be interpreted as multiplication. So we now have log y multiplying with 2y minus 7 equals to log 3 squared. Multiply it up, run the calculation, you will get 2y squared minus 7y minus 9. Factorize it and you will get your results as y plus 1, 2y minus 9. Run the calculation, you will get y equals to -1, y equals to 4.5. And the negative results will not be accepted. Hence, your final answer will be 4.5. And the last part, log with a base of 2p minus log 2q divided by log 2r multiplied with log r2. So the preset relationship here is a divide and a multiplication. So do not try or attempt to reverse it or write it into plus or minus. Don't do that. Okay, it's not permitted. Stick with what we have learned. So the 1 at the numerator minus will become divide, and for the denominator part, you will notice that one of them has a different base from the log base of 2 set by the question. So you're required to make some adjustment on that. So now log 2p divided by q. So that's all for our numerator part. And for our denominator, I changed the base of r into 2 now. Then I will get log with a base of 2 with a result of 2 divided by log with a base of 2 and r as the results. So I cross them off since they are repeating, and log 2 is actually 1. So now I have log 2pq divided by 1, and my final answer will be log 2p over q. So that's the single logarithm that the question is referring to. So moving on to the example 5. So this is the topic that most students struggle to understand. This part of the question, you're required to split things up. Change it from multiplication back into plus. So reason why that I can reverse it here, because it is the single logarithm there. There's no other things that was involved over here. So just stick to it, split it up. So now I will have log 416 plus log 4x. This is the only condition where you can split logarithm out. 16 can be interpreted as 4 squared. So I decided to bring out the 2. And for our log 4x at the back, it can be changed into p. So now we will have 2 plus p as our final results, because log with a base of 4 and results of 4 we cancel off and become 1. 2 times 1 is still 2. Moving on to the second part, we have log 4 bracket x to the power of 7 over 256. So the divide there, we can interpret it as minus. So change it up, we have log 4 x to the power of 7 minus log 4, the results of 256. So with this being set up, bring up the 7, we have 7 log 4x minus log 4 bracket 4 to the power of 4. So log 4x can be changed into p, so we got 7p at the front minus 4 as the final answer. Because log with a base of 4 and results of 4 will cancel off and become nothing. And in part 3 of this question, you are required to utilize what you have gotten earlier. So I bring in the 2 plus p and our 7p minus 4. Remember, their relationship is minus, so put down bracket accordingly so that you don't fall for the trap. So equals to 5. After I run the calculation, I gotten negative 6p equals to negative 1. P equals to 1 over 6. However, this is not the answer the question is looking for. They are asking for the results of x. So what's the x final value? Remember, as mentioned by the question, log with a base of 4x equals to p. So substitute the p equals to 1 over 6 into it. So we got log 4x equals to 1 over 6. Remember, you need to choose which form of the logarithm is the one most suitable for our question. So in this case here, we are supposed to change it back into indices form. So we have 4 to the power of 1 over 6 equals to x. And through your calculator, you get this result as 1.26 after correcting it to 2 decimal places. And that's your final answer for this question. Moving on to the last example that we have here. This one will be logarithm in simultaneous equation. So it is given that log with a base of 2 bracket x plus 2y equals to 3. This is our first equation. And the following one will be log 2 3x minus log 2y equals to 1. So a couple of adjustments that's required is to change the whole numbers into logarithm. The minus become division. So through identifying that, I list down the rules at the side. You don't have to list down the rules in your exam, it's just for your reference over here. So from 1, I change it into log with a base of 2. X plus 2y equals to log with a base of 2 bracket 2 cube. So x plus 2y equals to 2 cube. Just the 2 cube becomes 8. X plus 2y equals to 8. That will be our third equation. From 2, I changed the minus to become divide, and I adjusted the 1 into log with a base of 2 to the power of 1. So since 2 to the power of 1 is still 2, so I didn't specifically write down the 1 over there. Since both sides has log, just bring out the results. 3x over y equals to 2, and I change it into 3x equals to 2y. So I set this as our equation 4. The reason why I leave it so is because we have 2y at equation 3 already. So substitute equation 4 into 3. We now have x plus 3x equals to 8, 4x equals to 8, and x will have a result of 2. Lastly, when x equals to 2, substitute it into 3, and you will get 2 plus 2y equals to 8, 2y equals to 6, and y equals to 3. So that's the final answer for this particular topic. So after going through all the possible type of question, okay, I hope that you are able to understand the topic better. So remember this, you cannot rely on video or me to do all the heavy lifting for you. After watching this video, okay, if you really want to learn this topic and pick this concept up, you really need to do more practice. I couldn't emphasize this enough. Practice is the only way that you get better at something. Hopefully you understand this and you find this video helpful. If you have friends that are struggling, feel free to share this to them. And I wish you all the best in your upcoming examination. Thank you.